All right, so we're going to look at ways to transfer energy around in an object. Ways to transfer thermal energy. We've got three ways, and you should remember them. There's conduction, there is convection, and there is radiation. All right, so conduction is transfer of thermal energy by touching, so they bump into the molecules, bump into each other. Convection is transfer of thermal energy by a flow. Radiation is a transfer of thermal energy by light. So let's take a look at them. First one, conduction. The particles with more thermal energy vibrate faster. So more thermal energy, more motion, more vibrations. They collide with other particles and the energy is transferred from the high energy to the low energy particle. And eventually they'll balance out. So you can see here we've got a picture of a stove, right? This burner is hot. So you apply electricity to this piece of metal. That causes the metal molecules to vibrate really fast, getting very hot. Then you put the other pan on it. These vibrating molecules, as they're vibrating, bump into the molecules in the pan. And the molecules in the pan start vibrating. Now, at first they start vibrating in the bottom of the pan. But as those molecules vibrate, they kind of bump into the molecules farther up and they start vibrating all the way up the pan. Right? So we have a high energy molecule. It's vibrating a lot. And we've got a low energy molecule. And it's vibrating a little bit. So we got high energy, lots of vibrations. Then we got low energy, a few vibrations. What happens when we bring these two guys together? Well, when we bump them into each other, this high energy guy transfers some of it to the low energy. So they bump together. And then some of the energy gets transferred. Now, the high energy guy is now a medium energy guy. Now it has less energy, so it lost energy. And the low energy guy, well, he gained energy. So you can see this high energy, massively vibrating particle met up with this low energy particle, less vibration. They bumped together. The high energy guy transferred some of his energy to the low energy particle, and now he's gained energy, but the high energy guy lost energy. All right, so that's how conduction works. Now let's take a look at the next one. The next one is convection. And I use a certain color for convection. I use blue. Convection happens in fluids and gases. So the particles gain energy near the heater, often through conduction. So here, what we've got here is we've got a gas stove. Now, in a gas stove, you burn some fire. Well, you don't burn fire, you get fire. You burn some fuel like a methane. And that creates very hot gas here. That hot gas bumps in to the bottom of the kettle. And through conduction, the hot gas conducts heat to the kettle. Now the kettle conducts heat to the water in it. And the hot water starts to cycle up. So I'm going to use red here to indicate hot water. Hot water cycles up. And as the hot water cycles up, the cool water at the top cycles down. And when the cool water gets to the bottom, it heats up and cycles up. And and heats up, cycles up, and then the cooler water cycles down. So you get this constant convection current of hot water going up, cold water going down. Now this happens in water and in gases like air. So on Earth, if you have the Earth here, the sun heats the Earth up, so the Earth gets warm. The Earth gets warm. So we have a warm Earth. The Earth then heats up a layer of atmosphere. So then we get some warm air. Then that warm air starts to go up. So warm air rises. And as that warm air rises, cool air comes from the top and sinks. So we've got cool air. And this is a convective activity. Okay, so the particles gain energy near the heater via conduction usually. Warm water is less dense, and the heated molecules rise. As the warm water is rising, cool water replaces the warm water. Right, so water heats up, it's less dense, so it rises. Then the cool water replaces it. Then the cool water heats up, rises because it's less dense, and this cycle goes and heats the whole pot of water. Right, so that's convection. The last one is radiation, light waves. So this is the heat of the transfer of energy by electromagnetic waves, light. Heat radiation is in the infrared portion of the electromagnetic spectrum. So it's like close to red light. Now, all electromagnetic radiation can cause you to warm up. Any light, you go up to any light, you put your hand by any light bulb. See, I'm blocking out the light that's lighting this up, and my hand is getting warm. I'm putting it by another light bulb, it's getting a little less warm, but all light can warm you up, but infrared is the best at doing though. Thermal energy from the sun can travel through the vacuum of space at the speed of light, about 300,000 kilometers per second, so no particles are needed as in conduction or convection. Heat radiation can also travel through gases like the atmosphere. The heat from the sun, the electromagnetic waves from the sun, travel through the atmosphere, warm the earth. The best surfaces for transmitting or absorbing radiant heat are white and black surfaces. Car radiators, sorry, we need to redo this one. The best surfaces for transmitting or absorbing radiant heat are rough black surfaces. Not white. White is good at reflecting radiant heat, not transmitting it, not absorbing it. Rough black surfaces. Car radiators and cooling coils on the back of fridges are painted black to exchange heat quickly. The best surfaces for reflecting heat are white and smooth. Surfaces. So, you'll notice that people who live in the desert often wear white clothing, loose-fitting white clothing. And that white reflects infrared radiation. It reflects electromagnetic radiation, so it keeps them cool. Black surfaces warm much faster than white surfaces. Black absorbs electromagnetic waves, so it heats up better. White reflects electromagnetic waves, so it does not heat up as well. Now, the unit of heat that we are going to work with is called the joule. That is our unit of heat. That is a unit that you are going to get to know very well. In the olden days, there was one called the calorie. We don't use the calorie anymore. We use the joule. All right, so I hope you remember the three ways that heat can be transferred: through conduction, convection, and radiation.